In 1958, Chevrolet thought it had the future locked down. Picture it, Detroit, late 1950s. The sound of hydraulic presses echoing through cavernous factory floors. The smell of hot oil, fresh paint, and burning rubber drifting through open loading docks. America is drunk on horsepower, tail fins, chrome, and an optimism so thick you could almost taste it in the exhaust fumes. The suburbs are exploding. Highways are stretching across the nation like asphalt arteries. And every red-blooded American family wants a bigger, faster, shinier car than the one parked next door. And inside Chevrolet's engineering department, deep in the industrial heart of Detroit, a brand new V8 is being lowered into a full-size sedan for the very first time. It displaces 348 cubic inches. It looks nothing like a small block. It weighs nearly 100 pounds more. And Chevy truly believes, that this engine will carry them through the next decade and beyond. But what almost nobody talks about is how fast this engine fell from grace. Because the 348 wasn't just replaced, it was quietly abandoned, overshadowed by its own offspring, erased from the conversation, and ultimately remembered, when it's remembered at all, as the engine that couldn't keep up with its own ambition. You think you know why the 348 disappeared? Not like this. This is the shocking downfall of Chevy's 348W series. Back in the mid-1950s, Chevrolet had a problem that was growing bigger every single year. The small block V8, launched in 1955 and immediately hailed as a masterpiece, was brilliant in almost every way. Lightweight, compact, powerful for its size, efficient to manufacture, easy to modify. It transformed Chevrolet from a sensible family brand into a legitimate performance contender almost overnight. The small block was the engine that put Chevy on the map in ways that no marketing campaign ever could. But brilliance has limits. The bore spacing on the small block capped its displacement potential. You could only make the cylinders so big before the walls got dangerously thin. Torque was respectable, but it wasn't the kind of earth-moving, axle-twisting grunt that could haul a loaded station wagon up a mountain grade without breaking a sweat. And as cars got bigger, heavier, and faster, as American consumers demanded more chrome, more steel, more everything, Chevy needed something stronger, something that could move a 2-ton Impala like it weighed nothing at all. Something that would make Ford and Chrysler engineers lose sleep. So they started from scratch. Not a modification, not an evolution. A completely new engine, designed from the ground up with one goal in mind: brutal, uncompromising torque. What they created was the W Series V8. The W didn't officially stand for anything in Chevrolet's documentation. There was no press release explaining the name, no marketing materials that clarified the designation. But everyone who saw the engine understood immediately. This thing was wide, massive, heavy, built like a piece of industrial mining equipment that somehow found its way under a hood. The block, casting alone, looked like it could anchor a battleship. But the real innovation, the thing that made engineers raise their eyebrows and competitors scratch their heads, was the combustion chamber design. Instead of traditional wedge-shaped combustion chambers machined into the cylinder heads like every other V8 on the market, Chevy's engineers did something genuinely unconventional. They moved the combustion chambers into the top of the cylinder block itself. The cylinder walls weren't vertical, they were angled, and the piston crowns weren't flat. They were carefully sculpted, machined with complex contours that formed half of the combustion space when the piston reached top dead center. It was weird. It was unconventional. It was unlike anything Detroit had ever seen in a production V8. And for a brief, shining moment, it worked. The 348 launched in 1958 with a 4.125-inch bore and a 3.25-inch stroke, giving it exactly 348 cubic inches of displacement, a number that seemed almost impossibly large compared to the small block's modest dimensions. Compression ratios varied depending on the application, ranging from about 9.5.1 in standard passenger car trim up to a nosebleed 11.0.1 in high-performance versions that demanded premium fuel and careful tuning. Horsepower started around 250 with a single 4-barrel carburetor. Respectable, competitive, but the hot versions climbed fast. With triple 2-barrel carburetors, the legendary tri-power setup that would become synonymous with 1950s performance, the 348 made 280 horsepower. Chevy's engineers kept pushing. 305 horsepower, then 315, and eventually, in the most aggressive factory configuration, 335 horsepower screaming through those angular ports. But horsepower wasn't the headline. Torque was the real story. Over 350 pound-feet of twist, delivered low in the RPM range and delivered hard, the kind of torque that planted you in your seat before you even realized your foot was on the floor, the kind of torque that chirped rear tires on dry pavement without even trying, perfect for big cars, perfect for towing boats, perfect for drag racing, perfect for America in all its excessive, chrome-plated glory, and for a brief, beautiful moment, the 348 was a hero. You could order it in Impalas, Bel Airs, Biscaynes, and El Caminos. It powered family sedans during the week and street racers on Friday nights. Suburban fathers used it to tow campers to Yellowstone. Teenagers used it to embarrass their friends at stoplights. The same engine, serving two completely different masters. In NASCAR, early 348-powered entries showed genuine promise on the high banks. The torque advantage was undeniable on tracks where low-end grunt mattered more than screaming top-end horsepower. On the drag strip, serious racers discovered that a well-tuned 348 could yank a full-size Chevy through the quarter mile in the low 14s. That was serious, legitimate performance in 1958. That was the kind of performance that made magazine covers and built reputations. But there was a problem. Actually, there were several, and they were hiding in plain sight, waiting to surface at the worst possible moments. The W-Series design was clever, maybe too clever. Because the combustion chamber was partially formed by the piston crown and partially located in the cylinder block itself, the flame propagation path wasn't ideal. The spark plug sat at an awkward angle. The flame front had to travel around corners and through irregular shapes. At low RPM and moderate loads, this was manageable. At high RPM and full throttle, it became a liability. The angled cylinder walls created another issue that engineers didn't fully appreciate until the racing crowd started pushing hard. Those angled walls limited how large the intake and exhaust valves could be. There simply wasn't room for the massive valve heads that high RPM breathing demanded. Airflow at the top of the power band was restricted. The engine ran out of breath exactly when racers needed it most. And then there were the pistons. Those massive, sculpted, carefully machined slugs of aluminum weren't just expensive to manufacture, they were heavy, very heavy. Each piston carried extra mass because of its complex crown shape. And in an engine, piston weight matters more than almost anything else when you're chasing high RPM. At 6,000 RPM, the bottom end was already under stress. The connecting rods were working overtime. The crankshaft bearings were seeing loads they were never designed to handle continuously. Push it harder, the way racers always push harder, and things started to break. Mechanics began to notice it first, the guys in the trenches, the ones who actually had their hands inside these engines after races and hard street use. Burned pistons became almost routine. Detonation scars appeared on piston crowns with alarming frequency. Spark plugs came out looking like they'd been attacked with a blowtorch. Insulators cracked, and electrodes melted into unrecognizable lumps. Ring lands crumbled. Rod bearings showed wear patterns that suggested oil starvation even when oil pressure seemed normal. One Chevy technician who worked at a California dealership during this era reportedly said, "These things pull like a freight train from a stop, just brutal acceleration. Right up until they don't, and when they let go all at once." Still, Chevrolet wasn't ready to give up. They had invested too much money, too much engineering time, too much corporate reputation in the W Series architecture. Instead of acknowledging the 348's limitations and starting over, they doubled down. In 1961, they bored it out. The result was the 409, with a 4.3 125-inch bore and an increased 3.50-inch stroke. The new engine displaced 409 cubic inches, a number that would become immortalized in song, in legend, in the collective memory of an entire generation. Compression climbed as high as 11.25.1 in racing trim. Horsepower jumped to 360 with a single 4-barrel, then 380 with dual quads, and finally, in its most famous and most celebrated configuration, 409 horsepower, 1 horsepower per cubic inch, the magic number that separated serious performance engines from everything else. Torque soared past 425 pound-feet. Magazine testers ran out of adjectives. The Beach Boys wrote a song about it. On paper, the 409 made the 348 look obsolete overnight, and that's exactly what happened in the marketplace. The moment the 409 arrived in dealer showrooms, the 348 became the other engine, the one you ordered if you couldn't afford the real performance option, the one racers avoided unless they had no other choice, the one that sat on parts department shelves while customers specifically asked for the big one. Nobody wrote songs about 348 cubic inches. Nobody bragged about it at drive-ins. It became invisible. But the real damage wasn't just a marketing problem. It wasn't just perception. It was engineering reality catching up with ambition. The same fundamental design flaws that limited the 348 now became impossible to ignore in the larger, more powerful 409. At higher compression ratios, detonation became a constant threat that required constant attention. The awkward combustion chamber shape was too compromised to support the aggressive ignition timing that maximum power required. The engine would ping and knock at the slightest provocation, pulling timing and losing power exactly when you needed it most. And airflow, especially on the exhaust side, was choking the engine at high RPM. Those angled ports simply couldn't move enough spent gases out of the cylinders fast enough. Volumetric efficiency dropped. Power curves flattened. The engine felt like it was hitting a wall at the top of the tachometer. Chevy tried fixes. Bigger carburetors helped a little. Hotter camshafts helped a little more. Improved ignition systems reduced some of the detonation sensitivity. Engineers experimented with different piston designs, different port shapes, different everything. But the truth was brutal and unavoidable. The W Series had reached its ceiling, and that ceiling was lower than anyone wanted to admit. Drag racers knew it first because drag racers always know first. Stock car teams figured it out during long races when reliability mattered as much as raw speed. By the early 1960s, serious competitors were pushing engines harder than ever before, demanding more RPM, more power, more durability under sustained abuse, and the 348 simply couldn't survive that world. Main bearings wore fast, showing copper underlayer after just a few hundred miles of hard use. Pistons cracked at the ringlands, sometimes spectacularly. Oil temperatures spiked into dangerous territory during extended runs. The bottom end simply wasn't strong enough for what the top end was being asked to do. One drag racer from the era later recalled pulling down a 348 after a single weekend of competition and finding aluminum from the piston skirts smeared inside the cylinder walls like melted candle wax. It looked like the pistons had tried to escape through the block, he said. That was the last 348 I ever built for competition. The writing was on the wall, and Chevrolet's engineers could read it clearly. And then came the final insult, the killing blow that the 348 never saw coming. In 1963, Chevrolet unleashed something new at Daytona. It wasn't public at first. It didn't have a flashy badge or a marketing campaign. The racing press called it the mystery motor because GM wouldn't confirm what it was or where it came from. But the people who saw it on the dyno and on the track understood immediately. This engine was everything the W Series wasn't. True wedge-shaped combustion chambers machined into conventional cylinder heads. Straight intake and exhaust ports that flowed air like water through a fire hose. Better valve angles for improved breathing. Better cooling passages for sustained high RPM operation. Better durability under the kind of abuse that destroyed W Series engines in a weekend. This mystery motor would evolve into the Mark IV big block, the 396, the 427, the 454, the engine family that would dominate American performance for the next 2 decades and beyond. And overnight, the W Series was dead. Chevy didn't announce it. They didn't hold a press conference or issue a statement. They didn't celebrate the end of an era or acknowledge what the W Series had contributed. They just moved on, quietly, efficiently. The way corporations always move on, when yesterday's innovation becomes tomorrow's liability. The 348 quietly disappeared from performance catalogs and option sheets. No more factory development, no more racing support, no more evolution. While the new big blocks revved higher, flowed better, and made more power with less drama and fewer failures, the 348 was left behind in junkyards, used car lots, and the memories of mechanics who had cursed its name. Even the legendary 409, the engine with the song and the reputation, was living on borrowed time. By 1965, the Mark IV engines had taken over everything that mattered. NASCAR, NHRA, street performance, magazine covers, bragging rights. The W Series was officially, completely, undeniably obsolete. Production ended without ceremony. Tooling was scrapped and sold for salvage. Blocks were melted down and recast into something more useful. And the 348? It became a footnote in automotive history, a curiosity, an answer to trivia questions at car shows. That's the part most people miss when they talk about this engine. The 348 wasn't a bad engine. It wasn't a failure of engineering or imagination. It was a transitional engine, built for a specific moment in automotive history that disappeared faster than anyone expected. It was designed for torque, not RPM, for heavy sedans, not lightweight muscle cars, for the late 1950s, not the horsepower wars that would define the 1960s. But history is ruthless. History doesn't grade on a curve or give partial credit for good intentions. By the time the muscle car era exploded into mainstream consciousness, the 348 had nothing left to give. Its architecture couldn't evolve beyond its original limitations. Its flaws were baked into the fundamental design of the block and heads. And Chevrolet, always pragmatic, always focused on the next quarter's sales numbers, chose progress over nostalgia without a moment's hesitation. Today, the 348 survives mostly in restored Impalas and period-correct builds where authenticity matters more than performance. You'll still hear one rumble at car shows, that deep, lazy, lumpy idle that sounds like nothing else on earth. You'll still see those distinctive crossed flag valve covers and triple carburetors gleaming in the summer sun. And for a brief, beautiful second, it feels like the king of the road again. But now you know the truth. The 348 didn't fall because it failed. It fell because the world moved faster than it could. It was bold, innovative, genuinely powerful for its time, but trapped by the very design decisions that made it unique. And that's what makes its downfall so shocking, because without the 348, there would have been no 409. Without the W Series experiment, Chevrolet might never have understood what a true big block needed to be. Without this flawed, ambitious, ultimately doomed engine, there might never have been a Mark IV at all. If you enjoyed this deep dive into one of Chevy's most misunderstood and forgotten engines, let me know in the comments what story you want to hear next. Another forgotten V8 that deserved better? A legendary rivalry that shaped automotive history? Or an engine that changed absolutely everything? And make sure to subscribe, because the next story is even wilder than this one.